Okay, so I will be talking about the hybridization of ethanoic acid today. So firstly, we're gonna focus on the central atoms in this, which are these two carbons, which we can name carbon A, carbon B, and then there's oxygen A and oxygen B, as they all have different, as each of these elements, they have different hybridizations. Okay, so firstly for carbon. I'll be showing the electronic configuration of carbon first. This is it's 1s2, 2s2, and 2p2. So if we talk about carbon 1 here, carbon A, sorry, then the hybridization of this carbon will be 1s2, and the 2s and the 2p orbital sublevels will combine to form sp3 orbital, and the electrons are all equally shared in each of them. Carbon 8, this has an sp3 hybridization, because as you see there are 4 bonds that are related to this carbon, showing that this forms a tetrahedral structure. As all the bonds that are related to this carbon are single bonds, that therefore you can say that all of these are sigma. All these single bonds are sigma bonds. And thus their sp3 hybridization takes place, which forms 4 equal orbitals. Then coming to carbon B. Carbon B, as you see, has three electron domains, 3 electron domains around it, thus showing that it has a trigonal planar shape. So for the electronic configuration after the hybridization for carbon B will be 1s2, and here, and this is a little different, in this your 2s will combine with only 2 of the 2p sublevel orbitals to form sp2 hybridization, and their 1 2p orbital still remains, and here also the electrons are equally shared. This carbon has a double bond related to it, and this double bond shows that there is 1 sigma bond and one pi bond, and this pi bond is formed by the p orbitals, which is there in the sp2 hybridization. Thus in this case, there are 3 different equal sp2 orbitals formed and 1 p orbital. Next, coming to oxygen, the electronic configuration is 1s2, 2s2 and 2p4. So for oxygen, we'll do oxygen A first. For oxygen A, after hybridization, you get 1s2 here in this oxygen there is the sp2 hybridization takes place exactly like how it took place in carbon, and here as there are 6 electrons in the outer level, they get distributed again equally, so there will be only one free electron space in the sp2 orbitals and one in the p. This basically shows that the two orbitals that have 2 filled electrons, these are your lone pairs which oxygen has, and this is one bond pair which ends up forming the sigma bond, and the other bond is formed by the 2p orbital, which is the pi bond. And in this also 3 equal sp2 orbitals are formed, and there's one 2p orbital. Now if you see oxygen B, there's a different hybridization to this. This is because there are 2 single bonds associated with it along with the two lone pairs. So in this case the hybridization will be, the electronic configuration will be 1s2, and this will be sp3 hybridization because of the fact that there is no double bond associated with this specific oxygen, and as there is no double bond associated with it, that means there is no pi bond. No pi bond means that there is no p orbital, and thus it just shows there are four equal sp3 orbitals. sp3 orbitals that are formed. So basically, as we get to know the different hybridizations of all, we can see that we can finally draw the hybridized form of this atom. So basically, I'm going to be using different colors for the different hybridizations. So basically, firstly, the central carbon atom. If you take central carbon atom is this, central carbon atom. It has 3 sp2 orbitals around it and 1 p orbital. So this is your sp2, and this one p orbital, which we can here call pz orbital. Okay. Along with this, now next to it is the next bonded to this carbon B is the carbon A, which is sp3 hybridized. So I'm just gonna change the color. So we'll get sp3 hybridization has four orbitals. These are sp3 Now bonded to the same middle carbon on the other side is oxygen, and this oxygen is the sp3 hybridized oxygen. I'm going to be drawing the two lone pairs as well, which is this one and this one. These are the lone pair orbitals. Okay, now bonded to this carbon, as you can see in the diagram, is the other oxygen A, but this oxygen has this bond is a double bond, which shows that this oxygen is also sp2 hybridized. So you get oxygen, and you get sp2, and have your p's and orbital. Now we will show all the hydrogens that are also bonded with it. So there's hydrogen here, hydrogen, so this is a sigma bond here, sigma bond, sigma bond, sigma bond, sigma bond, and then sigma bond and sigma bond. So the total sigma bonds are 1, 2, 3, 4, 7. Then this bond, these pz orbitals here form half pi bonds each, half pi, which totally add up to 1 pi bond. So basically this is how ethanoic acid is hybridized.